and welcome to Spacedout. I'm Sarah Bagan. Joining me today is Graham Lau. Graham, welcome to the show.
Yeah, thank you.
What chemicals compose supernovae, and how much of that matter exists within our human biology?
And so the cool thing about where we come from, our elements inside of us, the atoms that make up our bodies, they're not just from stars. We're not just stardust. We are made of stuff that has formed through a lot of processes in the history of our universe. All of us contain some amount of hydrogen that formed during the Big Bang. Relatively about 3 minutes or so after the birth of our universe, the primordial hydrogen and helium was forming. And so you have hydrogen atoms inside of you. I have hydrogen atoms inside of me. Everyone does. Our planet does. All plants and animals do. It's all over us. And this formed during the formation of our universe. And then when we start having stars forming, so we formed hydrogen, helium, and some lithium in the Big Bang. And then later, when stars were forming, the very earliest stars were only composed of hydrogen and helium and a little bit of lithium. And inside of those primordial stars, those very first stars, reactions started occurring, these nuclear reactions, where the nuclei of these atoms, of hydrogen atoms, for instance, started getting smashed into each other. And helium nuclei could start getting smashed into each other. And there was enough energy and enough pressure inside of the star to overcome the barrier of repulsion. So these nuclei, they're formed of lots of protons and neutrons, that they're positively charged molecules, or positively charged nuclei. They don't want to come together. There's actually an energy barrier trying to push them apart. But inside of a star where the temperature is extremely high, the pressure is very high, it squeezes these things together and overcomes that barrier, so they can actually then go through the atomic processes of becoming new nuclei, new atoms. And so inside of stars, we start seeing things like carbon and nitrogen and oxygen, and then larger and larger atoms start forming inside of stars until you get to around iron. There's iron 56 and nickel 56 are basically the heaviest nuclei that are forming inside of stars. And so very large stars especially start building up these cores of iron and nickel. To get anything heavier than that, there's actually another energy barrier, basically. When nuclei get heavier than iron 56 and nickel 56, the energy inside of the nucleus is such that it's more favorable for the nucleus to break apart. And so inside of stars, even though there's lots of pressure, lots of temperature, there's too much of a barrier to overcome with that iron nickel
levels. That's where supernovae then come into play.
Oh, so interesting. Gosh, I love it.
And there's so many different kinds
of supernovae too. It's not just like one way of a star for exploding. There's actually a bunch of different types of supernovae. Some of the brightest ones actually come from smaller stars.
Yeah, and that's where metal particles can be found. So what metals can we see in the smaller stars?
Yeah, so when these supernovae are occurring, that process where all this material is being blasted off in one giant, explosive event, that then produces a lot of neutrons, and those neutrons are basically driving themselves like bullets into the middle of these nuclei, and they're building up larger and larger nuclei. So then we start building all these metals. We start building uranium and plutonium and all of these other things, and europium and einsteinium.
Silver as well, no?
Yeah, silver, gold, mercury, so many other elements and lots of metals. However, so that was the basic understanding for a long time, is that supernovae were required to get these larger things. But only in very recent time have we now started using gravitational waves to look at larger stellar events in the universe. For instance, neutron stars merging. It turns out in this process of these extremely dense neutron star mergers, they actually create another energetic event that blows off a bunch of new atoms. And so one of them from LIGO, there was a paper that came out, I forget how many times more mass than the Earth in gold was produced. I want to say it was like 3 or 5 times more mass of the Earth in gold alone was produced during one of these neutron star mergers. And so it turns out that not only are we Big Bang stuff and star stuff and supernova stuff, we also have some stuff inside of us that happens in these other, cosmic events where stars are merging and making black holes and large
massive neutron stars.
From an industry point of view, I'm wondering if people will start to mine stars for gold and silver and other precious metals. You know,
It makes you wonder for alien life, right? So we have that idea of the Kardashev Scale, if you've heard of that before in astrobiology.
no.
So the Kardashev Scale, and there's been a lot of variations on it now. The original Kardashev Scale is trying to place how alien civilizations, and our civilization too, how civilizations can be classified based on the amount of energy they use. And so the original Kardashev Scale is that a type 1 Kardashev civilization is basically using all the energy available to it at the surface of its original planet. And then a type 2 civilization is a civilization that has learned how to harness the energy of its home star or stars of its own solar system. And then you have some larger ones after that are using all of the energy of a galaxy, all of the energy of the
Wow,
universe.
this is so interesting.
That kind of
Beyond. There's actually a really great book that I have here.
So
called Star Maker.
in the second stage yet. We need to learn how to harvest the solar power from our sun.
Well, yeah, so we're not even type 1 yet. So we actually have not yet learned to harvest all the energy from our own planet to use all the energy available to us. We haven't figured out nuclear fusion yet, for instance. And there's a lot of other sources of energy and a lot of other ways to consume and produce energy that we haven't come to yet.
Recent conversations that I've had with people in the space sector discussing using solar from space, solar energy from space, to power everything here on Earth. I mean, we're starting to think about it at least, but you're right, we haven't yet learned to harness the energy on this Earth, and that's something that we need to master before being able to organically move forward. That's really interesting.
I think also mastering
Ourselves and how we use that energy and how we access that energy.
Oh, I love that.
We look at in human history, we've done some beautiful things in the development of culture and science and technology, but we've also done some very terrible things, and we've stripped resources from the environment without thinking of the longer term scale impacts to the environment, to people in certain regions who live in the systems where we're removing resources from. And so, that colonial mindset that has, happened throughout time for a lot of peoples, we've applied that colonial mindset to the resources of regions as well as to the people inhabiting various regions. So
here's a question for you. How can astrobiology benefit the environment here on Earth?
Absolutely. I will argue in favor of that. I think part of astrobiology, trying to understand where we've come from, what it means to be human, what it means to be living in this biosphere, how life came to be here, but also whether or not we'll find other life out there. Mm-hmm. It makes us think a lot too about civilizational longevity. And to have a conversation about that, you also then have to think about impacts to a biosphere, how as a species, our actions and our attitudes affect the biosphere around us, affect our world. There's the idea of the Gaia hypothesis that the Earth itself is a meta-organism, a larger organism. And if we are just part of this larger organism, then we really do owe it to the organism to treat it better.
Yeah.
And so I think and a lot in astrobiology, and any of us who are interested in space, you always hear those people who say, like, why are we spending money on going to space? We have so many problems here on Earth. It's a very common claim from a lot of people who, one, don't understand how little money we actually do spend on going to space compared to other things. But also it has that problem that most of us who are thinking about space exploration, our human future in the solar system and beyond, about the potential for alien life, most of us are also applying what we've learned to the problems here on Earth. And so space exploration is one of the places where we actually are actively trying to benefit the planet and other humans.
Innovative technologies can be applied to various aspects of humanity here and just propel us forward, that excites me. That's what really excites me. Graham, can you please explain what are the major components of astrobiology and how can that help us understand the stars?
Astrobiology is our quest to understand the nature of life in the universe. Or even more generally, just our quest to understand the nature of life. And so astrobiology isn't a specific discipline. It really is a way of thinking that brings together scientists, engineers, philosophers, artists, and thinkers from a variety of disciplines to work together to try to understand what life is and to frame our place in the cosmos. And so a big part of that is trying to understand our physical origins. Where does the physical material of our universe come from? Where does the physical material of stars and planets and asteroids and comets and planetoids and all these things come from? And how does that relate to what we are as living beings? Life is this planetary process that has occurred on our world, at least. And we see a lot of beautiful variation in what life does. And we're only just now beginning to explore what life really is and trying to figure out how life here is related to potential life elsewhere. And so a big part of that is understanding the formation of elements inside of stars and inside of supernovae and in other areas as well. We're actually made of atoms that have come from a lot of different processes from across the universe. Some of our atoms are very old, and some of our atoms inside of us are actually very, very young. We all have atoms inside of us that were formed in the atmosphere extremely recently, over the past year even. So there's this process that occurs inside of our atmosphere where cosmic rays, these very energetic particles, high energy particles, a lot of them in our solar system are hitting us from our sun, but there's also galactic cosmic rays coming in from the galaxy and coming down into our atmosphere. And sometimes these cosmic rays can hit an atom of nitrogen-14. And when that happens, it can actually cause that atom, the nucleus of that atom, to be converted into carbon-14, which is a radioactive form of carbon. And this carbon, then through various processes in the atmosphere, becomes carbon dioxide. It gets taken in by plants. It gets eaten by the food that we eat. If we eat plants, if we eat other animals, we are taking in carbon-14 from the atmosphere that was created very recently from cosmic rays.
So how is that going to affect us then?
So we do have carbon-14 decaying in us all the time. You actually have radioactive material inside of you. But we've evolved on a planet where this is happening to us. There's radioactive material in the rocks below our feet. There's radioactive materials in our building materials, in our walls, in our electronics, and then we're also eating it in our food. But it's nothing to worry about. It's a natural form of radiation that we've evolved to have at a constant basis all the time around us. And the cool thing is this is the basis of radiocarbon dating. It's how we can actually date things that have died very recently by using the radioactive decay of carbon-14 inside of their bodies. And so when archaeologists are looking at artifacts from an older civilization and they're using carbon dating to try to figure out, the age of these artifacts, they're actually dating when the materials, if it's like wood, for instance, when the tree that created that wood, we're basically looking at the time since it died. Because when an organism dies, it's no longer taking in fresh carbon-14. And so as soon as it dies and it stops taking in fresh carbon-14, we can start watching the slow decay of carbon-14 inside of that being's materials, be it bone or wood, and it tells us how long it's been since that thing passed away.
So interesting. Wow. So I understand that you also study for extraterrestrial life beyond this planet. Can you tell me what you may have discovered in microbial life that could reveal something about us?
Yeah, there's a lot that we're learning about the potential for life out there, and maybe we'll find life that is like us. Maybe we'll find other animal-like or plant-like beings. Maybe we'll find worlds that have lots of microbes all over them. Life on Earth was microbial for most of its history. It wasn't until a few 100 million years ago that other organisms like plants and animals and fungi came around. And so most of Earth's history is microbial life. But that doesn't mean that other worlds follow the same process. Maybe some worlds get to larger, animal-like life forms much faster, or maybe it happens a lot slower for some worlds. But just trying to understand life here on Earth, a lot of us in astrobiology have traveled to various environments, extreme environments, to try to understand the limits of life, at least life as we know it. How hot can it get for things to still be living, and how do they survive in hot environments? How cold can it get? How much salt can life handle? How much acidity can life handle? By understanding these different limits, it starts to help us to kind of bound the physical and chemical and geological regions of the universe where we might actually find other life.
can it be something so alien that it can only adapt to that sort of climate, and therefore that is extraterrestrial life existing in certain parts of the universe, in that climate?
Yeah, so life as we know it definitely has a limit in how hot it can get. The highest known temperature for living things here on Earth is 122 Celsius. Much above that, it becomes very difficult for the molecules, for the biological molecules to even function. They start breaking apart because of the high temperatures. That doesn't mean, though, that there couldn't be some other kind of life out there that's figured out how to survive at many hundreds of degrees Celsius. So, for instance, life as we know it cannot survive on the surface of Venus. It's 450 Celsius, 92 times the surface pressure that we have here. So it's extremely hot, very dense. Living things from Earth cannot survive that environment, but maybe there are alien systems that have figured out how to survive extremely high temperatures. But then we start looking at the temperatures of stars. The surface of the sun is about the same temperature as the core of our planet. It's extremely hot, a few thousand degrees Celsius. And then inside of the sun, it gets even hotter, many millions of degrees. And so life as we know it, and most likely other kinds of life, could not survive on the surface of a star, at least not life based on organic materials, which brings up a kind of fun thing to think about, right? Like, are there beings out there? Is there, a form of life out there that consists entirely of metals? Is there a form of life out there that doesn't actually have, the physical kind of form that we know of as bodies? And that starts kind of pushing us to something of a fringe for science, because it starts pushing us to a place where we're now thinking, with our imaginations of what could be possible, but maybe not as much, maybe not as probable based on what we currently know of how the universe works. And that's one reason I love science fiction a lot. I'm a huge sci-fi nerd. I have been my whole life. It's fun to think about what's possible. For instance, consciousness. We don't even have a definition for life, let alone consciousness. We really don't know what consciousness is. And there are various ways to look at it. Some people take a very reductionist approach, and they think that consciousness stems from the brain itself, that we have evolved through time and through many steps through the evolutionary history, a brain that allows us to have consciousness. But there's another realm, and this realm called panpsychism suggests that consciousness is actually everywhere in the universe. And what our brains are actually doing is tapping into consciousness. And then there's a whole bunch of different ideas kind of in between these two realms. So either consciousness is just inside of us, or it's everywhere and we're tapping into it. And there's a huge realm in between. And so there's a lot of potential for what consciousness could be. And one reason I'm excited about finding an alien civilization is they might also have their own ideas of what consciousness is. And by comparing notes, we might actually have a good chance of understanding it together a little better.
I think consciousness is within us, and it's everywhere as well, all at the same time. It's almost like the quantum realm, It's just everywhere, and it's in all the places you can't see as well. And I'm interested to know that personally, because you seem like a very spiritually developed person, I'd love to know how your spiritual understanding affects your scientific work.
I do consider myself to be a very spiritual person, and I meditate a lot. I think a lot about what it means to be human, but also what it means to be aware of ourselves in the cosmos. And as an astrobiologist, I think a lot about, what is the experience of being alive? Are there things about our experiences that aren't the same for other life forms? Do they experience time differently than we do? Do they experience, perception, actually seeing and feeling and smelling and hearing the universe? Do they have different ways of perceiving the universe? I think a lot of our language, how we communicate and how we share, how we dream, how we explore, and how we conduct science is very much based on our perception of the universe around us. And it does beg the question, is there part of the universe that we're not perceiving directly? And if so, is there a way for us to have some understanding? And so that's where I personally start feeling a little bit more spiritual. I start feeling a connection to the universe. because I start feeling like there is this grander part of the universe that maybe we're not aware of yet, but it's there with us. And I think for a lot of people, you look up at the night sky and you can't help but wonder what's out there. You can't help but see that starlight from so long ago and just wonder what was happening when that starlight left to travel here to our planet in that other place in our galaxy.
Yeah, I love that. That's exactly what I do. I just wonder, and therefore I have so many questions. I want to know what you think about alien life. Do you think it exists? Do you think we'll come across something anytime soon from our discoveries and our research so far?
Yeah, so there's a longer answer to that as well. First off, applying logic and thinking scientifically, we have to admit we could be alone. That maybe life only happened here on this one planet in the entire cosmos. And because of how logic works, since we don't have any actual examples of life out there, we have to admit that that's one possibility. There is a possibility that we are the only thing that ever happened. And if that is the case, then I certainly feel that we have an imperative to preserve life and to spread life elsewhere. But if you start just looking at the potential out there for other life forms, we have at least 100 billion stars in our galaxy, maybe as many as 400 billion stars, which means that there could be something like 400 billion to 1 trillion planets, somewhere in that range, in our galaxy alone. And just the sheer number means that even if that's just a small fraction of those other worlds could have life, then it means that life must be abundant, because we have so many galaxies, hundreds of billions of other galaxies, themselves likely having many hundreds of billions, if not trillions of worlds. And so we just start looking at the math. It almost seems that if life is possible elsewhere, if it ever happened, even just one other time, then it has to have happened many, many other times. And so even though I admit as a scientist that we could be alone, I feel as a human that we're not alone. And I feel like there must be alien life out there. And I think we're very close to making some detections as astrobiologists. Looking on Mars and Venus and Europa and Enceladus here in our own solar system, if there ever was life in these other worlds, I think we're very close to figuring that out. And right now with our new telescopes coming up, the James Webb Space Telescope and some of these other telescopes could really help us to look at alien worlds around other stars and to see signs of activity of life, potentially even industrial and technological activity of life on these other worlds. And so I think if there is life out there, and it's fairly common, I think we're going to find some rather soon, at least in the next century, if not sooner. There's a very real existential threat of alien life as well. What if alien life is malignant towards us, or just doesn't even care about us? So the same way that a human swats a fly, or when you step into the bathtub or the shower and you wash your skin, you are killing a large number of living microbial organisms and even animal life that thrives, these small microscopic animals that thrive and eat your dead skin cells. You are killing some number of them and just sloughing them away into your drain, and they're going into the septic system. And we don't think about them very much. We don't often think about the organisms that we can't even see that we're destroying. When you boil some water, you're likely killing a bunch of microbes that were in that water already. And that's good for us, but it's not so good for those organisms. But what if alien life has the same attitude towards us that we have oftentimes towards other organisms on our own planet? If that becomes the case, then we should worry if they want our resources here on our planet, and they don't worry so much about what happens to us along the way. And this has been, fodder for a lot of science fiction.
But why would they want our resources? I mean, what's so special about what we have that they probably don't already have, and probably have even better resources than us?
Yeah, it depends on what kinds of resources alien life might want. So for instance, we humans have been moving a lot of Earth. Over the last 10,000 years, we have learned how to move Earth in mass quantities to extract metals from that material. And so even though, an alien, civilization, if they were looking for metal resources, they'd have much better luck by just going and taking an asteroid from our solar system, mining that for metals. Here on Earth, we've actually taken those metals and have concentrated them already together into our buildings and into our cars and into our technologies that might be a better source for alien life to scoop up and harvest. There's also been a lot of people talking about like the water here on Earth. We have liquid standing water at our surface. And it's a good point to think about. There are other worlds in our solar system that have far more water than we do. Europa itself, its subsurface ocean, has more fluid water, more liquid water inside of it than we do in all of the Earth. And so there are other places to harvest water as well. And so it is a very good question. Why would they want our resources? And that's often one that's not really addressed so much in the science fiction story. Why do they come and take all of our resources? And the truth is, we just don't know what an alien civilization might want of the Earth if they were to come here.
What do you think it might be?
I mean, yeah, so I think and I hope that if a civilization can overcome its own boundaries, hindering it from developing advanced technologies, that if a civilization can fly through interstellar space, can travel through the galaxy to visit other worlds, I would hope that they would not be warlike. They would not want to destroy other life forms. They would not want to harvest other life forms and their resources. And so I truly hope that if we do find an intelligent extraterrestrial civilization out there, that they will be peaceful and want to have a conversation with us as opposed to wanting to destroy us. But we do have to consider the latter.
I want to know, what do you think about star seeds, or are there humans merged with alien DNA here on Earth, planted all over the place? And that's one of the theories that I've come across. What do you think about that?
I've read some of that kind of stuff before, and there was a paper out some years ago claiming that octopuses have alien DNA. But the truth is, there's no evidence to support it. Because if we look at our DNA, we can understand, we can see the linkages of our DNA to all the other creatures on the Earth. Octopuses don't have anything in their DNA that is entirely alien that we should expect. We can look at our DNA. We share genes with many other organisms across our planet. Some of our genes we all share across the planet. We all have ribosomes. Living things all have ribosomes, and we all have genes for them. And then, we have a lot of similarities to all these other beings, whereas if there was alien life and it had its own DNA, and if it was entirely alien life, if we had the same origin, then maybe alien life would have similar enough DNA to actually, mix with ours, and we would probably still see some sign of that. But it doesn't make any sense to think that alien life would have such similar DNA if it had a different origin, that it could somehow then hide its DNA inside of our own. There's really no scientific way to really allow for that, because again, we can look at our DNA and we can explain everything in our DNA. There are some regions that people used to call junk DNA or viral. We've had viral insertions of DNA into us over time that are now evolving with us over time, but none of this is unexpected or alien in nature. And so, for people who really believe this has happened, I don't mean to diminish their belief by any means, but I definitely think as far as the science is concerned, that there's no evidence to support such a belief. We don't know what the future holds right now for biotechnology and for the laws around biotechnology. And so it is good to be a little cautious. However, so what 23andMe and these other companies, Ancestry and these other groups, what they're doing when they get your DNA is they're doing a very simple extraction of the DNA itself, and then they're sequencing the DNA and analyzing that using something called bioinformatics. Using current technology, you analyze the sequences they get. And so if they get sequences they can't explain, it's not because it's alien, it's because for the most part, these groups are using actually cheaper technology than we would use for a higher end. So if you want to pay like $10,000 and have your genome sequenced really well, people can do that. They could do a very good job sequencing your DNA, but these other companies, you're not paying them enough money for them to actually go through and really do the full workup
Or
on
are
your
you saying that
DNA.
maybe my DNA is somewhat complex and therefore they're unable to identify it with the technology that they have, and the DNA samples they usually receive is probably easier to locate and identify because they have a pool with more of it.
Yeah, and so when you get your DNA analyzed, they're comparing that DNA to a library of known genes, known DNA from around the world that's been sampled from other people. And a lot of that other work has been done extensively, and we have really good knowledge of the genetics of various peoples from different places on the planet. But even then, there's going to be some amount of their DNA they're not going to be able to sequence, given the way that they're applying the technology. And so for my own workup, some of the DNA that I submitted also wasn't identified based on their methods. It doesn't mean that DNA is unidentifiable. It just means that their methods weren't really the kind of methods you need to identify that. What you would need is really to go the other route. I know that the author Carl Zimmer, he's a really great science communicator. I know that he's had his entire genome sequenced. And so if you want to pay enough money to a good research lab, they can definitely sequence your entire genome, and that will get better. So now that we do have companies like 23andMe and Ancestry and these other groups who are doing this, they're going to get better and better as they have more samples to work with, because they'll have more things to analyze against in their libraries. But also the technology to do a really full workup will get cheaper and cheaper. The technology for sequencing will get better and better. And so eventually, I mean, I do think that in the very near future, like genetic medicine will be a thing. We've talked about this for a very long time in the sciences and science fiction. Eventually, you'll go into your doctor and they'll look at your genome, and based on your genome, they'll be able to prescribe medicines to treat various issues you're facing, various diseases or sicknesses, illnesses, based specifically on your genome. So the medicine will be complementary to your genes. So right now what we do is we have medicines that fit to the best of our ability for most people. But some people have severe allergic reactions to certain medications. Some medications just don't work as well for certain people. So I think in the very near future, genetic medicine is going to be a huge thing. We're going to start seeing a lot more developments in technology based on the structure of our genetics, of our DNA. And this is very far-fetched. It's not going to happen anytime soon, so don't worry about it. But I do think in the near future, mid-distant future, we're going to have the ability to control our epigenetics as well. So we're going to find ways to turn on or turn off the regulation of certain genes inside of our bodies using medicines and various technologies that will drive our epigenetics, how our genes are being expressed, to allow us, for instance, to reverse aging.
That's going to modify the entire human species.
It will, yes. And so you might have heard a lot about like the idea of the singularity, that we are quickly coming to this point in our technology where we are going to hit an exponential jump in our technological capability, specifically in the processing capability of our computers. And a lot of people around this realm of the singularity have been talking about this idea of transhumanism. What happens when we start going from our current biological human selves into something post-biological?
What is the post-biological human being? And what does it look like? What do we expect from it, or us, our future selves?
Will we merge ourselves with machines? Will we download our brains into computers? Or you might be following along with Elon Musk and Neuralink. They just had they showed a video of a monkey playing Pong with its brain. They're trying to figure out how do we create a brain interface with a computer. And so the post-biological, it doesn't necessarily mean that it's not organic anymore. We may continue being organic beings, but we might start augmenting ourselves with things like a Neuralink, like a brain lace, that allows our brains to then connect with other machines around us. Maybe that brain lace itself will end up becoming something like telepathy, or talking to each other without actually using our mouths.
I've done that before.
Yeah, and so there's a lot of questions of where we're going to go once we start augmenting and changing ourselves in our biology. And it's important to astrobiology because we have to wonder, if there are advanced alien civilizations out there, Are they still in the window where we are of developing, agricultural technology, industrial technology, and then computer and space technology? Or are they somewhere beyond where we are? Are they already post-biological? Are they artificial intelligence, super intelligent artificial intelligence? Are they computer-based? Are they silicon-based life now? What do they actually look like now? And what kinds of realms of thought and technology do they have that are well beyond where we are currently? And it's a good question to ask. And it goes back to that existential issue too, that maybe part of the reason that we haven't even been contacted by alien life yet is that we haven't made the transition to some part of evolution that they consider like a capstone for us to have to rise above so that we can actually join them. And we just don't know yet. We don't know what the future holds for humanity, but I think it is important that we start thinking for the future and we start preparing now, because people are right now working on this. They are working on things like Neuralink. They are working on things like genetic medicine. They are working in this realm of how we'll change ourselves. And so from the philosophical standpoint and from the humanist standpoint, we really need to be prepared for what happens to us and what potential negative consequences might come from all of this work as well.
So what measures can we take to prepare ourselves for the future?
I think the most important thing, honestly, is to get more people thinking in a longer term mindset. Now, we've evolved to think of things in the moment that happen right now, or that happened an hour ago, or an hour in the future. We can look, a few days in the past and remember what happened. But if you start, if I ask you what happened, on March 30th of 2011. It's a very good chance that you wouldn't know exactly what happened that day for the entire day.
Nope.
I wouldn't either. We don't have good memories like that. Most of us can't look back to a specific day and remember the whole day.
I think it's because we've become lazier as a species with the development of technologies, making up for the time we need to spend to think to solve a problem.
Yes and no. So I am a fan of memory, the ancient memory techniques, and trying to improve our memories and the way that we can actually use our own minds to remember things. But I think it's also very much just our biology. It's how we've evolved. We evolved in a place and time where our biology needed to be more cognizant of the immediate needs of our bodies and of our family, our tribe. And I think really becoming a global species, and then hopefully in the near future becoming an interplanetary species, and maybe even an intergalactic species, I think it's going to require us to start thinking on a longer term scale than we've evolved to think. I think we need to start making that change ourselves to think for the future, what's going to happen in a century or a millennium, or even tens of thousands, hundreds of thousands, millions of years from now. How can we start preparing for the future generations of humans to set them up for success, and also so that they're prepared for the potential consequences of the things we're doing right now?
Don't you think we've started to do that? And if not, what do you think we need to do that hasn't been done yet?
I think some of us are doing that. I think in general, especially like governments, if you ask a politician to draft a piece of legislation, a law, that is focused primarily on the people who will be around in 100 years, there's no way they're going to do that. They don't care about that. Most politicians can't be long-term thinking because most of their constituents, most of the people that they represent, aren't long-term thinking. People want to talk about the problems they have right now and not think about the problems of future generations. It's one reason why discussing climate change, discussing long-term environmental impacts to our planet is very difficult. We're only just now starting to bring this into the public dialogue, and even then, there's just still such harsh blowback, and people fighting this idea that we actually can impact the environment because they don't want to think on that longer-term scale.
What if we replace politicians with futurists?
I mean, well, but then they become the politicians, right? And so I think what we need is we need politicians who understand business and law and the military, but we really need politicians who are scientists and historians and artists and teachers, and we need politicians who are futurists, who are philosophers and deep thinkers who want to think about these larger scale problems and how they can draft legislation and work together to deal with our issues now, but also in a way that considers future generations. But we really need that kind of thinking, not only to start addressing the problems that we're creating right now, but to address the problems that aren't even aware of that we're creating right now. There are things that are going to come down the pipeline that we need to be prepared for, that we need people to be to understand that they need to be ready for things like genetic medicine and human brain and computer interfaces and things like this. For artificial intelligence, there's a reason why a lot of people in the tech community have been arguing that AI is coming. We're already using machine learning and a not very sophisticated form of artificial intelligence in science and engineering and data processing. But people right now are thinking, how do we create a super intelligent artificial intelligence? And they're working towards making that happen. And we need people in that process to also ask, should we do this? How can we control that intelligence, or at least help guide it to make good choices? How can we help it, to understand some level of ethics that we understand to avoid it potentially destroying?
Have you seen Sex, Death and Robots?
I haven't yet. I really want to watch that. Yeah, it looks really good. What happens to us if we create robots? Will they replace us?
It's quite scary, actually. Because it could be realistic in the future. What I wanted to know is, I'm fascinated by what you just said, having politicians who are well-rounded and wholesome in terms of their thinking and their experience, so they can bring that to their decision-making and shape policies in the way we need it to be. So I think that we also have a responsibility, not just the politicians, that we all do as a society, to absorb the importance of that as well. Because if we don't believe in it, if we're not educated that it's important and we need to act on it and we need to be a part of it, they won't care. So we have a responsibility to educate them and help them understand why it's important to be a part of, to think about and to support now rather than later, And I think that's what's missing.
I agree entirely, and I think we humans, we are very reactive. We are an emotionally reactive being, but we can be better. We can think rationally. We can think spiritually, and I think one of the best ways for us to help other people around the world to gain some insight into who they are themselves is by developing meditation programs. I think meditation should be something that we teach in schools. I think it should be something that we share, our meditation practices in our daily lives together. For me, I as a scientist, a young scientist, I was facing a lot of mental health issues when I was trying to complete my research to earn my PhD. And one thing that really helped me, not just to complete the research and to really understand my place as a scientist, but one thing that just helped me to understand who I am. And to really start framing myself in my own studies of life in the universe was meditation.
Thank you, and you just got me buzzing, so I might just meditate or do some tuning.
I love it. That's great. Yeah, me too.
Awesome. Have an amazing day, Brian. Thank you.
Yeah, you too.